If I flipped a coin 10 times and said I got exactly 5 heads, you'd find that believable. If I said I got 10 heads or 10 tails, you'd say that's pretty unlikely to get them all in a row. That's really unlikely. Even more so, if I flipped a coin 100 times and I said I got 100 heads, you'd say, yeah, I don't believe that. It's not a fair coin if you get 100 heads or 100 tails. But if I said I got exactly 50, you might think, well, that's still possible. It's the most likely, but you'd expect something a little bit further, maybe a little bit above or a little bit below. If I got 40,000 flips, and I said I got exactly 20,000 heads out of 40,000 flips, you'd say, yeah, that's too nice. That's too neat. That seems to be quite unlikely. Because you'd expect if it was really a random coin, it'd be a little bit above or a little bit below, just because of random chance. And so what statistically you would expect is that the majority of the time it would be maybe 100 above or 100 below exactly at 20,000. So that's actually what we call the standard deviation, is the average deviation from the mean. How far above or how far below the mean will you be on average? And that's called the standard deviation. And that really is what the bump in the bell curve comes from, is all of the values that fall within plus or minus 1 standard deviation. Now, as you get further out from a standard deviation, the values start to fall off exponentially. And so that gives you the tails of the bell curve. And so it's really just a matter of central tendency. And that's really what drives the bell curve. So thanks for the question. Have a good day.